Can everyone hear me? Yes?
Yeah, brilliant. Okay. This is the PyconUK building, built in Chicago in the late Victorian era. It's the tallest load-bearing brick building ever built. And what that means is that the weight of the whole building is taken through the outside walls and some of the internal walls. You can see at the bottom, as it fans out here to get thicker, the walls are 6 foot thick. That includes the internal walls. So there's hardly any space at the bottom. And part of the reason that this is the tallest one ever built is that with bricks, the strength is based on the air, roughly based on the area of the brick, but the weight is based on the volume of the brick. So you kind of reach a natural limit and you just can't get any higher. And then there was a radical change. The mass production of steel completely changed architecture within just a couple of years, to the extent that some buildings were half built with brick, and then architecture had changed so much that they finished the rest of the building with steel on the inside. This is the Wainwright Building, possibly one of the first proper skyscrapers, not actually as tall as the PyconUK building, but is built with this internal steel structure. That takes all the weight, which goes down the middle of the building, and the bricks are just added on after. You can see it's just a facade that's been sort of placed on. They're there for, to make it pretty, make it weatherproof. People don't like the rain and wind going through the building, so they have to put something around the outside. And this radically changed the way architecture worked. Up until that point, when you wanted to build a building, you had a book of sort of design patterns that you could just reuse. You could just do the same thing as people had been doing for hundreds of years before. You could add your own little twist. You could experiment a little bit. But it was all basically the same. And then we hit this period where there were no design patterns anymore. There was nothing. They just had to start again from scratch. And you had to really think about, well, how were these buildings going to look? What's the shape going to be? What's the internal structure? All of a sudden, we've got these sort of 6 foot of walls disappears. You've got so much more space. What do you do with it? And from this vacuum, this man came about, Louis Sullivan, the father of skyscrapers. And he wrote a very long essay on this thought. He really thought hard about how do we decide what the use of space and things like that should be. And he came up with this very catchy quote. It is the pervading law of all things, organic and inorganic, of all things physical and metaphysical, of all things human and all things superhuman, of all true manifestations of the head, of the heart, of the soul, that the life is recognizable in its expression, that form ever follows function. This is the law. As you can, very catchy, It got shortened down to form follows function, which is a bit better. So his thoughts on how you should go forward, that's the idea that you should look at the function of a building, and that's what should take you forward to how you build it, how you space it out, led on to American functionalism. There's also a branch of psychology called Functionalism, which also came out at about the same time, leading on from this sort of same idea. Design should be driven by the intended function of a building. This was relatively controversial. This was new thought, that you think about how people are going to use the space, and that drives your design. Previously, it had been form follows precedent. And that was perfectly acceptable up until this point, and then there's a change in thought. If function is satisfied, beauty will follow, which kind of implies that beauty and elegance come from good solutions to problems, particularly to hard problems. And that's something we can appreciate we see it in maths and things like that. A beautiful solution is a good solution to a hard problem. And then this wonderful quote from Paul Graham, great essay, Taste for Makers. Wild animals are beautiful because they have hard lives, that their shape and what we think of as their elegance is because they are very well adapted to a specific situation. And this led on to European modernism. Now, this European modernism came about in the early 1900s and was very heavily influenced by functionalism, but slightly different. We're talking Le Corbusier, Bauhaus, Mondrian. It was furniture, architecture, art. It affected an amazing array of things in Europe. But they were more focused on simplicity for the sake of simplicity, which had been inspired by functionalism, because one thing that came out of functionalism was simplicity of buildings. But their focus wasn't on meeting the function. Their focus was on simplicity, to the extent that Albert Loos in Ornament and Crime argued that ornamentation was immoral and degenerate, that if you ornamented something, that ornamentation would be part of a fashion, and the fashion would change. The ornamentation would be useless within, a decade or a short time. And the waste was sort of an inherent bad. So does form follow function? There's a descriptive interpretation that you could say that you are saying this is an inherent truth about life and things like that. We certainly see in nature, function, survival, reproduction is what drives the form of animals and things like that over time. And in any adaptive system, the system must adapt towards serving the function, or it's maladapting. And at this point, we're starting to sort of think maybe, form follows function is a tautology. Of course it's true. It's just sort of, that's the way things are. There's also the prescriptive interpretation, which is the idea, should we try and make the form of something follow its function? Should we try and make it exclusively follow the function? No. I mean, aesthetics are important. Beautiful objects are easier to use, and it's nice to have pretty things. Or we could say yes. Aesthetics can actually be part of the function of an object. The function of cushions is to make the sofa look pretty. The function of a painting is to improve the look of a room, and that is, part of filling a function. Function can vary over time and place. It's not a static thing. The same object, a cushion, can have different functions. It can be used to raise a child higher at the table. In this case, the thickness of the cushion would be important. Ornamentation is necessary. It's part of the function. The child has to like it. It can't be ugly. It can't, the child will refuse to use it if it doesn't like it. Use a cushion to support your back. Small and thin's better. Ornamentation's irrelevant, and this is where Albert Loos would come in and say, well, ornamentation isn't irrelevant, it's actually wrong, because it could make it go out of fashion. You might want to replace it more often as it sort of, the style of ornamentation changed over time. So, how does this apply to code? One of my favorite topics, controversy and arguing about the right way to do things. But when we argue about which form is correct, such as styles, patterns, languages are a form of expression, we're really arguing about what the intended function is. So if I say one thing is better than the other, we can't really compare the forms because, both things can be good in different ways. What we're arguing about is the intended function that we think it should have. If you agree the function, then finding the correct form that follows from that is generally quite easy. And then you need to change the argument to be one of arguing about function. So I want to go through a couple of examples. Tabs versus spaces. So tabs express intent. I want this indented by 3 levels. I want this indented by 2 levels, which allows people to choose different widths per level. So one person might prefer, 8 spaces worth. One person might prefer 2. It doesn't matter. They can both have what they want. You're just sort of expressing the intent. Flexible to the end user in that case. Some people want it wider, some people want it narrower. It's up to them. They're exact. You can't do half a tab. You can only say, this is it. Or well, you can if you mix tabs and spaces, but we're not allowed to do that. Spaces. Spaces allow people to copy and paste with confidence. This is, certainly it's becoming a bit less of an issue these days as more applications are sort of tab aware, but we've all seen it where someone's copied some Python code into a forum, into an email, any of that, and it just all gets squished up to the left, and no one can sort of tell what's going on anymore. Spaces are flexible to the developer. If you want to align your code, your arguments with the name of the function, and that I personally hate that style, but it exists, that you sort of have everything aligned sort of to a random number of spaces, or if you want to align all the equal signs in a series of expressions, you can do that. You can be creative. You can do all sorts of things. So what is the function of indentation? Is indentation visual? Are you exactly laying out some code on the page? Or are you defining meaning? And so the argument about tabs versus spaces isn't about tabs versus spaces. They just happen to be the best forms for two different functions. And what we need to resolve is, are we using indentation for lexical purposes or for visual purposes? And this kind of reminds me a little bit of an argument certainly we used to have quite a few years ago about fixed layouts versus flexible layouts. And I did web development in the days when, you were given a PSD and it had to look exactly like that, and no one would. It had to look like that on every browser, and you weren't given any flexibility. And we're in a much better place now. But it's that same. That's not to say that fixed layouts were wrong. If your intention is to make something that looks exactly like this in lots of places, that's the way to do it. Another example. Java versus Python. Are there any Java developers in? Okay, I'll try and be nice then. Java is safer. Java is definitely safer. Some errors can be caught before runtime. The argument, I argue about Java with Java developers, and they think we're insane for using Python. And there's definitely a class of Java developer that wants to use Python and sort of loves it, but there's some Java developers I have arguments with, they think I'm insane for using Python because it's dangerous, because people can access your code. They can get into your class, and they have access to, private functions and private attributes and all sorts of things. And Java's quite defensive. It provides protection against your colleagues. Quite verbose, lots of boilerplate, less powerful and expressive, and so if you're building a large Java application, you tend to need more developers than if you're building the equivalent the equivalent application in Python. And I think it's roughly 10 lines of Java to 1 line of Python is sort of an estimate of how much. So each individual developer on a Java application is going to have a smaller impact on the total. Python. Duck typing can definitely cause surprising errors. It can also allow surprising behaviors. If you've got you've written a function and people put completely weird things in, but it happens to work. They've got 2 methods on there, the only 2 methods on the object that you're using. It works, and it certainly wasn't what you were expecting anyone to do with it. And it might not work with the rest of your code, but if they want to use that one function, they want to pass weird things into it, if it's good for them, that's fine. We're all adults here. Very powerful and expressive. One developer can do immense amounts. You can also do a lot of harm. And you can do immense amounts of harm with Python. And you might not even discover the harm for years. I'm sure lots of us have worked on old code bases. You sort of take it over, there's sort of 5 years of code there, and you discover awful stuff. And you think, I can't even work on this. The immense amount of refactoring it will take. It'll take me longer to fix this than it took him to write it. And one developer can just do immense amounts of harm. So what is the function of these languages? Providing safety. That's not a bad thing, you know. If you're a company and you sort of need a product, you can't risk it going wrong. It's got to be sort of to a reasonable degree of steadiness. It might be the right choice. You don't want one rogue developer, one bad hire, to be able to sabotage your product for the next 10 years. Long-term maintainability. Speed of development. If you're a startup, there's just no way you can hire that many people. There's no way you can put that amount of effort in. You've got to take a gamble, just hope that, you know, all your developers are good developers, and that you go for sort of great speed of development. One last example, I want to just look at the function of testing. There's been loads of talks on testing, and we get disagreements between integration testing, unit testing. Should you do one? Should you do the other? Should you do balances of them? Should you do any testing at all? I mean, probably not anyone in this room, but we've definitely worked with people who don't really want us to do that much testing. You know, managers who go, okay, if you want to do some testing, but hurry up, you know. As far as I can see, the product works. So what is the function of testing? Increasing your confidence that the code works, speeding up development, convincing other people that the product works, checking that it's good enough that you won't get shouted at. This is probably the main reason most people get into testing is sort of, you know, you've developed a product, you need to do a quick change on it, you put it into production, I messed it up, you know, you do another quick change trying to fix that, and you're just breaking it, so you think, I know, I'll write some code that checks whether my product actually works or not. And I'm fairly confident that's one of the main motivations for most people, that it's good enough, sort of smoke testing. Annoy your customers less. Help you design your code. It's definitely the case that you can use testing to help you think about your code in different ways. So if we're arguing about what type of testing we should be doing, the argument isn't about, is this type of testing better than that type of testing? We're arguing about what's the reason for testing. And if you find out what that person thinks the reason for testing is, you'll be much better able to come to a conclusion. That's it. Thank you. Slides are available on my website, and please feel free to argue with me now or email me.
We have a few minutes for questions. People who would like to ask questions can come to where I'm standing here with my hand in the air like a lunatic.
Do they have to come like a lunatic, or you're standing like...
Normally, that's
okay,
fine.
right.
So, when I'm having a discussion with someone about the sort of forms and the functions, do you have kind of an idea of an exercise or something you can do to make sure you're getting the right mappings from the form to the function?
So the classic exercise is the 5 whys. And you can do a form of that with people. You don't need to necessarily go 5, but people say, you know, I think this is the right way to do it. And you say, why? And normally at that point, that's enough to just shut them up and the argument ends, you know, and they have to go away for a few days and they come back. And yes, you just sort of dig in. Not dig in as in, you dig into why they think that. A common usage I find myself doing is when people say it doesn't work. And you say, well, why do you think it doesn't work? And then they sort of stop, and then they have to kind of, well, you know, it's not doing what I want. Well, what do you want it to do, and what's it actually doing? Essentially you're debugging people and trying to work out, you're sort of digging down. And also, the other key thing to remember, I'm a very argumentative person, and I get excited and get very angry and shouty with people, and I quite like it. It's like play fighting, you know, it's sort of, but as long as no one gets hurt, it's good. But the one thing you always have to remember is they're not idiots, you know. If someone's a complete idiot, there's no point having an argument with them ever, you know, because they're just going to, oh, does he just sort of walk away? So they've got a good reason for their beliefs. I mean, you might disagree with their reason, but they've got a good reason for their beliefs. So, yeah.
Come on, that's fine. But while you're coming up, I also have a question.
Oh.
How do
Your voice came from over there. It confused me.
It's terrifying, right? How do I ensure when I am trying to build my own products that I have a full understanding of what the intended function is before I start building my product?
I have no idea, and that's the hard bit, and that's the bit. It's why so many people skip that, because it's hard to do. And you actually have to sit down, you have to think really hard. And, well, why are we building this app? What's the point of it? And actually, if you skip that and just sort of get on with building it, life's a lot easier and you don't have to sort of think as hard, that's why it gets skipped. I don't know, and that's not my area of expertise. I let other people do that. I'm an implementer.
Hi, what do you think about Scala?
I actually don't have any terribly strong opinions about it because I haven't had enough time to play with it, and I haven't met any people who use it who disagree strongly with me. I've got a few friends who've actually moved from Python to Scala and they think it's wonderful, so I kind of respect them, but I don't know enough about it yet.
All right, and that's our time. Thanks very much, Ed.
Thank you.